I joined Trimble 2012 and I work as a BIM specialist. Main duties are supporting Finnish customers, giving trainings, consultations and webinars. And before Trimble I worked as a bridge designer between 2005 to 2012 at Sito Oy. I got my master's degree in civil engineering in 2008. My major was bridges and vessel structures. So my agenda for today is a case study of grandfather's bridge project and a little bit more hands-on demo for new tool, Tekla Grasshopper Live Link, and some reinforcement tools for bridges. On 2011, Helsinki City wanted to connect Mustikkamaa, which is a national recreation area, to urban city area, new city area of Kalasatama. And then they wanted to have something really nice there, so they formed a bridge design contest, which Bontek won with their proposal. So it's quite near Helsinki city main railway station, so if you are visiting Helsinki, that's definitely worth visiting. So here's the main railway station. And a pedestrian bridge, so no cars allowed. For use of the citizens of Kalasatama mainly. And you can get from Mustikkamaa to other places like Korkeasaari, which are really nice. So really this joins a lot of nice places together and probably much used bridge. Some basic information of the bridge. And the main span is 144 meters and the total length is about 160 meters. And as you can see, the foundation conditions here are quite different on each support. So on the Mustikkamaa side, it's on solid rock, and on Kalasatama side, the foundation is on piles. And steel arch bridge, and also there is underpass for boats under the bridge. So how did the information workflow work during the design? Of course, the initial road site information, road alignment and ground conditions were established, and the final geometry of the arc was done by the architect using MicroStation, and the arc geometry was transformed to Tekla structures. And the designer modeled the arc and the other structures and detailed the whole bridge, which could be used for fabrication information and block division. And also the third-party inspections could be done from the model because it contained all the details. So really accurate model at this stage already. Coordination meetings could be done, and also quality documentation were done using the model and were done using the model. So a fully detailed model was given for contractor tendering. And the winning contractor gets the job. And as you can imagine, for the owner, when the model was given to the contractor tendering, the owner could really be sure of that what the quantities of the materials should be. So they could really evaluate the contractors that are they bidding low or are they bidding high. All the details were included, and at this stage the model sharing was taken into use. Rebar fabrication could be done from the model, and really accurate quantity takeoffs. To addition that the contractor used the model to get information from the model, like the quantities and the rebar information and fabrication information. The contractor also used the model for additional modeling. They modeled scaffolding, supporting structures, formwork and layout points directly to the model. So as you can imagine, it's quite easy way to visualize and easy way to check that the supporting materials and the additional materials and modeling really are in the correct place, and they worked and with the design, and they are possible to do. So that really helped the contractor. And also measuring actual points, if the piles were in dislocated somehow, so they can check there that it's still, the structure still works. And additional drawings were made if they were needed. So after the additional modeling, contractor also used the model with all the details and also the scaffolding and supports and things like that. They used it to visualize scheduling with Task Manager, and they could deliver the plans directly on tablets. So, as you can imagine, the construction coordination was quite transparent and well visualized, and the coordination meetings were really nice because they could really show to the site workers that what's going on and what's coming next, what needs to be done. We are talking about this detail here and here. So really good visualizing tool. And also they could progress tracking of the project. Is it on time? Is it delayed? Things like that. And site delivery planning was also done using the model. So they could check that the logistics of the work site works, that there is no things are coming to the right place at the right time, so they are not in the way of the, for example, piling machine here. So, from initial design to fully detailed constructible model, to contractor for the additional construction modeling, to construction and measuring actuals, and schedule planning and site management to see that everything works like it should. Let's see a video of the project.
So far, modeling has referred to the designer's tool, and it has applied more to 3D design than real data management. A good way in which modeling can be used in different parties, and for finding the right information from the right place, and in ensuring that all information is correct and up to date.
When inviting tenders and during the bidding phase of this project, there was really only the model, and that was the starting point. In addition to contracting, the model was also used for logistics, specifically for scheduling, meaning that the contractor added the schedule of when the design process was to be finished into the model.
For example, the design schedule of the steel structure, the manufacturing schedule, and the installation schedule were in the model all the time, allowing us, for example, to make sure that fabrication was well ahead of installation.
Building with a building information model is indeed considerably more efficient. It reduces errors and makes the flow of information faster and clearer. When a structure works in the model, then it will work in the field as well. This means considerable savings, both in terms of time, and thanks to it, also money.
For this project, the model information was used during the fabrication of the reinforcement and also during the installation process.
The model is quite illustrative. When you have the reinforcement right there in front of you, it's not only a drawing or catalog, it allows us to ensure that the structures are correct and everything is done appropriately. If all parties are going to utilize the same model, the software has to be able to model both concrete and steel. Throughout the project, TechLab model sharing was utilized with several project parties. It was convenient because this meant that the models were always up to date. Traditionally, setting the models has required a lot of work. Whenever a change is made, we want to make sure the new information available to others, which has required sending it through Project Ring. With model sharing, we could just do the read-in, enter the changes into the model, and they were instantly available to everybody.
The quality of construction improves instantly when everything is done right the first time, when possible errors are anticipated in advance, and there is no need to go back later to make corrections.
All right. So let's go to the demo part and to the Tekla Grasshopper Live link and reinforcement tools. So what I have here is I've opened Rhino with the Grasshopper extension and just a new model of Tekla structures. So nothing done yet specifically. And I'll start by sketching a profile in Rhino. I will just sketch quite simple ridge cross section here, and I will also define here a road geometry, or what could be a road alignment here. These can be moved easily in Rhino. Let's add some double curvature here. Just make some cantilever here. Alright, now we have the cross section and the road And then I will just wire these together like this. And as you can see here, you can see now that the cross section is aligned with the geometry, but it's not yet extruded throughout the geometry. So I will wire this one. Now you see that basic item here. Let's add a few more components. Let's get the solid there, and let's add from the Tekla tab page this item component to Grasshopper, which creates the item in Tekla. And I will just wire it here. And as you can see, the solid item appeared in Tekla instantly. And now what we can do here is when we modify, and that's why it's so lively, because when we modify something in Rhino, you can see that the modifications are automatically and instantly transferred to Tekla. Like this. And also, if we need to modify the cross section, you can modify that one. Like that. And you don't need to do this by sketching. You can use Excel sheets, you can use parametric profiles. There are a lot of possibilities you can do with this one. This is just quite simple example of what you can do. Okay, now we have the bridge deck here, but of course it's nothing without the actual reinforcement or the details. So I think this is pretty cool thing that now if we take these reinforcement tools, we can apply reinforcement to this bridge deck. Let's just pick the part and show that I'm now using the main bars, so longitudinal reinforcement to the bottom. And finally select the part which we want to reinforce. Like this. Let's do another one with the crossbars extension. So let's do the same thing. Like this. And again, I will just show the direction and the part that I want to reinforce. see the reinforcement follows really nicely the deck structure. See all the reinforcement follows the deck structure and they're in correct place. Okay, well this was just really quite simple example, but if you are a more advanced user of the Rhino, you can also have something like this. You can also have something like this. So the basic principles of using this is the same. So they are components which are telling how the geometry are used and how the geometry is handled, and then it's transferred to deck structures. And the cool thing is that you can really modify this instantly. For example, if I want to make some more supports there, let's put 5. You see that it works quite nicely. And we can also just if we want to, for example, put the support height, it's 4,000. And this was the profile, so support height means that the height of the beam on supports. Fine. And you see the support height is instantly modified. And this can also be reinforced because the logic is exactly the same than with this previous simple example. Let's put some width. And also the cool thing is that, for example, if I change the width of the deck, you see that all the railings and lamps are moving together. So that is also what you can do. So quite agile way of working, or if you have conceptual design that you need to explore many different kinds of variation to some place. So this is really easy thing to do. And also you can use this for more simple profiles. And these reinforcement tools and other tools also work for if you are familiar with the previous beam extruder or simple native deck structures to objects, so they work also there. Alright. But that's for the demo part. So small summary. Increasing model information is constant use during the project, and the scalability and the possibilities of the model information expands during the project. More information that you put to the model, the more information you can get from Tekla Structures has really good, nice modeling and detailing possibilities for complex geometries and bridges and infrastructures. And there are really good YouTube videos, for example, from this new Grasshopper tool, so check those